Namaste. Welcome to Youth TV Show. In the first episode of Our Planet in Perspective, my co-host Jenee and I will be in a conversation with Jorge Vazquez. Welcome to the show, sir.
Thank you.
Global warming and climate change, they are the defining issues of our time. How has the NASA revolutionized the understanding of our ever-changing Earth?
NASA has been at the forefront of what I call a technical and scientific revolution in understanding our planet using satellites, using Earth-observing systems orbiting our planet. And they have given us information when we hear about the issues of sea level rise, when we hear about the issues of the temperature in the atmosphere, when we hear about the issues of the temperature in the ocean. NASA satellites have been responsible for giving us all of this kind of information. And to give you a perspective, NASA now has, along with the National Oceanic and Atmospheric Administration, the longest satellite data record produced that goes back to 1980. So we have 40 years of measuring the temperature of the ocean over the entire globe. So that gives you hopefully a perspective on this scientific and technical revolution that NASA has been part of. And I also want to say quickly, this is not just NASA. This has been done in collaboration with the French Space Agency. It has been done in collaboration with the European Space Agency. And we've also, launched satellites in collaboration with the Argentinian Space Agency, just to give you some examples. And by the way, we're now also working very closely with the Indian Space Agency on launching a satellite. So this is very international.
And before we dive into our topic, can you tell us something about your journey at NASA?
Thank you for asking that. My journey started basically now almost 40 years ago. I finished my master's degree in oceanography, and then when I came to JPL, I finished my PhD, and it has been an amazing journey because during that period of time, I have been humbled to have had the opportunity to work with some of the pioneers in understanding our planet from satellites. And I have had also the opportunity, the other thing that I think has been just amazing for me is the international perspective. I've had the opportunity to work with scientists and engineers all over the world. And that has just been, so eye-opening for me. It gives you a completely different perspective. And I'll just say it up front here, because global warming, these problems that we're dealing with, climate change, are global problems. They don't belong to one country. So this is another issue. I'm so proud, of being involved with NASA from the very beginning. And by the way, I also want to say from the very beginning of this, and I was partly also on the team that made these decisions, NASA has had a policy that all of its data, all of its information is free access to any researcher, any scientist, anyone around the world that wants to use that information. That policy has been there from the very beginning.
Currently, NASA has 23 satellites looking at our Earth system to help us understand what's going on in our planet. How does this information contribute to the creation of a climate model? In short, how does NASA satellites help model the future of climate change?
It contributes to the information of our planet basically by telling us specific things. For example, the issue of sea level rise, again, has been a huge issue. And the satellite that NASA launched in 1992, the Topex Poseidon satellite, which I was there when this happened, gave us information on how sea level was rising on the order of centimeters. This is amazing. So these kind of technologies, NASA has been at the forefront from the very, very beginning. And we can talk more a little bit later about, why do people care about sea level rise? NASA has also, been at the forefront of information on the temperature of the ocean. Why is the temperature of the ocean? Why do we even care about that? Well, when you see hurricanes, storms, the temperature of the ocean gives energy to the atmosphere and creating those kind of storms. So this is extremely important in understanding the formation of hurricanes. And I'll also say NASA has been at the forefront of a satellite that was launched that measures how glaciers are melting. And that's been huge also in understanding in terms of, the supply of water, but also glaciers melting have a huge impact on sea level rise too.
The sheet of ice that covers Greenland contains enough frozen water to raise oceans by 25 feet across the globe. As the planet warms, glaciers melt, causing sea levels to rise.
The two biggest ice sheets of the world, Antarctica and Greenland alone, contribute to 1/3 of the total sea level rise that we observe. This information has been gained from direct measurements of massive ice. How has this information been used?
Well, the information on sea level rise is, for example, in terms of impacts of storm surges, in terms of, impacts of how to build, close to the ocean in the future. Those are critical issues with respect to sea level rise. We had a major year of hurricanes off the coast of Florida, and we could see the impacts of sea level rise in terms of, what happens when sea level rises. It also amplifies the storm surges that occur due to hurricanes hitting the coast. So all of these things can be predicted better now because of NASA satellites. It can help in predicting, how large of a storm surge are you going to get. I can give you an example too. As a child, because my parents would vacation a lot in Miami. This is a personal note. We would spend a lot of time on beaches in Florida, and a friend called telling me what happened in Fort Myers, which is on the west coast of Florida, where one of the hurricanes hit. It literally wiped out everything, hotels. Why? Because of the storm surge. So this is a direct consequence of some of the things that are happening because sea level rise. That doesn't mean the satellite's going to prevent the storm surge, because it can't do that. But it does mean it can give us information better on how to predict these things, and hopefully give people more advanced warnings in terms of but yes, this is very, very important in terms, that's just one example in terms of sea level rise. And yes, when we look at the Antarctic, when we look at we also look at Greenland. I have a colleague who's put in instruments in the Greenland ice sheet, to measure specifically, what's happening with respect to why are these glaciers in Greenland melting. And one of the amazing things he's found was that the glaciers are melting faster than we thought. Why? Because the oceans are also bringing up heat into the glaciers. Not just the atmosphere, but the oceans and the currents also bring up heat into the glaciers, and it's causing them to melt more fast. So this information is directly related to being able to predict sea level rise, which is very important for coastal communities. And one thing I want to say is, I think more than, I can't remember the exact statistic, but I think it was between 70 and 80% of the world's population now live within 100 kilometers of the ocean. So this is an issue.
The melting of glaciers has led to a lot of areas being abandoned due to rise in sea level. While it's very obvious that there's a threat of flooding to coastal communities, how do you think this is going to affect the rest of the world?
Yeah, I mean, that's a great question. And when you look at glacier melt, for example, the other issue is, how is it going to affect, the soil itself? How is it going to affect the amount of water that you have in a given community? I can give you, it wasn't exactly glacier melt, but here in California, we've had an extremely, harsh, what I would say, rainy season, which has caused, a lot of rain in the mountains. And that rain, some places in the mountains is snow. Eventually it melts. So California is now trying to, initiate new policies on how to capture that water. But it's not that easy, because glaciers also melt and the water comes off, but that water contains so much stuff in it from the soil and everything. So you have to actually have a mechanism, if you want to use that water, you actually have to have a mechanism to clean it and be able to. But yes, the other issue is, obviously, it can have an impact on communities nearby. If you have a lot of water that's melting because of glaciers, absolutely. that can be a huge issue.
How exactly do we know that the glaciers are melting? What tools are currently being used in the scientific community to collect data on these climate changes?
There was a satellite launched by NASA called GRACE. And by the way, another international collaboration that was in collaboration with Germany, the German Space Agency. GRACE specifically measures how mass moves on our planet. You say, okay, mass. Why do I care? Because if a glacier moves, it changes the mass at that particular location on our planet. So the GRACE satellite could actually tell us how the glaciers are melting on our planet. That was a huge breakthrough, in understanding our planet, because GRACE has given us information on what's happening in the Arctic. It's giving us information on what's happening in Greenland. It's giving us information on what's happening in Antarctica. So when you hear these news clips and when you hear information about, okay, the West Antarctic ice sheet is melting, or when you get information on the Greenland ice sheet is melting, a lot of that is also due to the measurements of the GRACE satellite.
The Surface Water Ocean Topography mission was recently launched in December 2022. How did this measure changes in river discharge and also impacts in coastal areas? How will this new invention impact data assimilation?
Thank you for that great question. One of the consequences of global warming and climate change is that it's going to have impact on what we call the Earth's water cycle. Basically, in a very simplistic sense, it rains over land, water gets into these rivers, the rivers transport the water to the ocean, then over the oceans, the water evaporates, forms clouds go back over land. That's the basic, simplistic model of the Earth's water cycle.
Heat from the sun causes the molecule to evaporate from the ocean's surface. Once it evaporates, it is transported into and through the atmosphere, where water vapor condenses, releasing its heat to form clouds. The water molecule might move halfway around the world before it falls as rain or snow. Once on land, it will either re-evaporate, be used by a plant, drain to the water table, or enter a stream. Streams and rivers bring the water molecule back to where it started, the ocean.
What the Surface Water Ocean Topography mission is going to do, and it's going to be an amazing breakthrough. It's going to actually tell us from a satellite, it's going to tell us the discharge of these rivers and the impacts in coastal areas and what happens in the ocean. So it's literally going to tell us, give us information on the entire water cycle on our planet. And of course, that's extremely important because in the United States, the Mississippi River, the Nile River, it's all over the world. These things are changing, and this changes the impacts of water supply all over the world. But it also has impacts directly on the water cycle on our planet, which we know is going to be changing because of global warming and climate change. So SWAT is probably going to be a huge breakthrough in understanding the Earth's water cycle, because obviously water is our planet. As the great Arthur C. Clarke said, why do we call this planet Earth when it is clearly planet ocean? So this is very, very important. SWAT's going to give us, the whole model of the Earth's water cycle.
There's a gap between what we know, what we have, and what we're doing. There's a lot to help mitigate climate change, but not many people know how to access it. What exactly are the barriers to accessing this information?
That's a great question. And one of the barriers is that now, as I mentioned, we have actually temperatures of the ocean from satellites that go back to 1980. Well, that's 40 years of data. And if you put that all on a computer, that can be difficult to access. That's what we call big data. But those are the kind of problems we want to look at. We want to look at climate trends. We want to look at climate change and those impacts. So one of the things NASA is now doing is to try to give, better access to data, because it has, again, as I mentioned, it has an open access policy, an open science policy, and NASA is now going to be collaborating. NASA is now going to be collaborating with Amazon Web Services to put the information on the cloud so people can actually access all of this information more freely and more easily. The hope is, again, that people will be able to run models more easily, integrating data more easily and all of that information, but also, again, using larger amounts of data, which is huge. That's the main barrier. How to access large amounts of data to be able to predict climate and to be able to predict what's going to happen.
Do we require any kind of specific expertise to understand the data that NASA has published, or is it comprehensible to laymen as well?
I think it depends. That's a great question. I think it depends on the level that you want to use the data, the information at. In general, no. I mean, you don't need any specific expertise, on the data itself. Other, for example, if you're looking at sea surface temperature of the ocean at one particular area, you don't really need expertise. You just need to understand this is the temperature of the ocean at the very at the very interface between the atmosphere and the ocean that you're seeing. That's what you need to understand. It's not the temperature of the ocean at 100 meters or 200 meters. It's the temperature of the ocean measured exactly at the atmosphere, between the atmosphere and the ocean, what we call the air-sea, boundary. Now, so that's, one of the things you have to understand is you do have to look a little bit at the documentation to understand exactly what it is the data means. Because we also have, for example, which I think would be really critical, soil moisture now. Well, soil moisture is measured in terms of how much water per given area, on the planet. You have to understand from those points, those technical points, what you're measuring to be able to use it wisely and for the particular application that you have. But in terms of you have to have knowledge about all of the data and how it was made and all of this. Well, one of the things that NASA tries to do along with its partners is not have to have somebody who wants to use the data read 30 peer-reviewed articles to be able to understand the data. That's one of the things that NASA and in collaboration with international agencies is really trying to make it a lot easier for everyone to have access to this information and data and use it. And that means not just scientists, but decision makers also. Management people who want to use it to make better management decisions because of climate change.
Is the existence of climate change denial a reality? Why do you think it exists, and what can we do about it?
I think, unfortunately, it is a reality. And I think the best thing that we can do, the most important thing, is be very well educated on the issue of climate and global warming. One of the things I hear a lot, is people say things like, well, the Earth's climate has been changing all the time. Why are we worried about it? We can't do anything about it. Certainly that's true, but what they don't understand is that the time scales in which we are seeing things change right now is like nothing we've ever seen before. The time scales in which the ice is melting in Greenland, the time scales in which the ice is melting in the Arctic. We've never seen things happen this quickly. The time scale in which we're seeing glaciers melt. The other thing people need to understand is when they talk about, well, again, everybody uses carbon dioxide. I mean, I've heard this so often. We breathe out carbon dioxide. What's the big deal? We need it to live on. Well, that's true. But we have gone now from 200 parts per million of carbon dioxide in the Earth's troposphere, which is the lower boundary layer in the Earth's atmosphere, to over 400 parts per million. 400 parts per million we haven't seen in a million years. So this is unprecedented, the levels of carbon dioxide that we're seeing. And what people need to understand is that cannot be caused by natural causes. It's being caused by human beings. And that's very, very critical to understanding also that these impacts that we're seeing are human-made impacts to climate change. It has a factor. It has a huge factor in what we're seeing. So I think the answer is, I think we need to all get very educated, very well educated on these issues. One further example I'll give, because people need to understand this. We know the energy that's coming from the sun because we have satellites that measure the incoming solar radiation. So we have an excellent idea of the incoming solar radiation from the sun. Nothing in the time series of that indicates that things are changing enough, to see the kind of temperature differences that we're seeing right now and that are happening. Again, an issue of time scales. Things are happening much faster and cannot be explained by changes in the incoming energy from the sun. So these are the things that people need to understand. And I think we all need to just be educated on this issue, because the climate denial, I hate to say this, is based on false information and non-facts, not factual information.
The real-world costs of climate-driven disasters are devastating, but the politics of mitigation policies, they continue to overpower the need for change. What is your take on this?
I think, we need to absolutely, and this is where I think it's not perfect, but for example, the Paris Accords, we need to have thresholds set, goals set to mitigate the issues of climate change. But there's two issues here that we have to keep in mind. Yes, we have to create policies to mitigate the impacts right now. For example, again, in coastal areas, we have to create policies that people understand in terms of housing and all of that, and the issues related to sea level rise. In California, as I mentioned, I'll say this again, we just had one of the hardest rains that we've ever had, one of the most intense rainstorms that we've ever had in California. And what are they doing now? Well, the state of California is trying to implement policies to basically be able to get, all of that water and make it clean to be able to use, because we don't have the infrastructure for it. So again, these policies have to be initiated. But the other thing I want to state up front too is, at some point, we also have to treat the cause of all of this, which is carbon dioxide in the Earth's atmosphere. And this is my opinion again, but that's going to require almost, I think, a second industrial revolution. But I think the optimistic things about this is the technology is there and improving constantly, from wind energy to solar energy to, I went to a talk at Caltech by a professor who is using basically solar energy to create hydrogen. Literally infinite energy source coming from the sun to create hydrogen, which would be, an energy source, a clean energy source also. We already have hydrogen fuel cars that have always, so the technology is there. I think that's very optimistic. We just need the will to turn this into a second industrial revolution.
Very well said. Thank you for being with us today. It was an honor having you here in the show.
Thank you so much for having me. It's such an honor to be able to do this. Thank you.
We will be back next week with a new episode. Until then, hope you have a great week ahead. Namaste.